Logical operators. Operators can act on sentences. When a logical operator acts on a sentence, or perhaps on a couple of sentences, the result is always one of the following statements. The sentence is true, the sentence is false, or we don't know whether the sentence is true or false. We call this unknown. Let's take a look at the binary logical operator, the word and. It acts on two sentences. Let's take two sentences for an example. If both sentences are true, then the result will be true when we act with the operator on these sentences. Otherwise, the result is false. An example will make this very clear. Let's take one sentence, which is a true sentence. The sun can only shine in daytime. And let's take another sentence. A cucumber is green. This is also a true sentence. Now let's operate on the two sentences with the logical operator and. The result is true, because the sentence, the sun can only shine in daytime and a cucumber is green, is true. It is made up of two true sentences. However, if we take one sentence that is false, the moon is always full, and another sentence which is true, for example, stars are visible at night, and operate on the and, we get the sentence, the moon is always full and stars are visible at night, and this sentence, this whole sentence, which is made up of a true sentence and a false sentence, is false according to the rules of the and operator. Let's take a look at another logical operator. This time it is also a binary operator. It is the operator or, and it acts on two sentences. But this time, if both sentences are false, the result is false. Otherwise, the result is true. So we only really need one of the two sentences to be true so that the whole sentence will be true. For instance, let's take a true sentence. The sun can only shine in daytime. And another true sentence, a cucumber is green. When we act with the or operator, we get the sentence, the sun can only shine in daytime, or a cucumber is green. And the result of acting with this operator on the two sentences is true, because they are both true. However, if one is true, the moon is, one is false, the moon is always full, and one is true, stars are visible at night, then the whole sentence, the moon is always full, or stars are visible at night, is still true, even though part of this whole sentence is false, because these are the rules of the or operator. It doesn't have to be logical or seem like it's funny. These are mathematical consequences of this logical operator. So the whole sentence is true. Now let's take two false sentences. The moon is always full, cucumbers are fruits. Both sentences are false. In this case, and only in this case, if we act upon these two sentences with the or operator, we get the sentence, the moon is always full or cucumbers are fruits, and the result in this case only is false, because both sentences are false. Let's take a look at a unary logical operator, the not operator. It's also called negation, and because it's a unary operator, it acts on one sentence. If the sentence is true, the result is false, and if the sentence is false, the result is true, exactly the opposite. So the negation, or the not operator, reverses the logical meaning of the sentence. If we take a true sentence, the sun can only shine during the day, and operate upon it with a not, we'll get a sentence, the sun can not only shine during the day, and this of course is a false, because the sun of course cannot shine during the night. Now let's look at the opposite. The false sentence, the sun shines at night. The sun does not shine upon us, at least at night. And we operate with the not operator on this sentence. We get the sentence, the sun does not shine at night. And this, of course, is a true sentence. And that's a bit about logical operators.